The next example that we'll take a look at is actually going to use a compound interest question. It tells us here that William borrows $9,400. So if he borrows it, that's going to be his principal. He borrows it at 10% compounded quarterly, so 10% is our R value. And we know that it happens quarterly, so that's going to be our I value. Okay, and he has it there for 7 years, so that's our end value. So we're trying to figure out the total amount that's due at the end of the loan. So we don't know what the total amount is. We know that the principal is going to be $9,400. The I value, we know that uh, R, and let me just quickly erase this piece. We know that R is going to be 0.1. So I'm going to take 0.1 because I divided 10% by 100 to convert it into a decimal. And quarterly means 4 times. So I'm going to divide that by 4, and this is going to give me my R value. And so 0.1 divided by 4 is going to give me 0.025. Okay? My N value is going to be the fact that it's in there for 7 years times compounded quarterly for 4 times. So there's 28 compounding periods in each over the life of the loan. Okay, so if I want to figure out the amount, I got to plug in my formula. So 1 plus I raised to the n. So my final amount is going to equal my principal of $9,400 times 1 plus 0.025 raised to the exponent 28. So I can clean that up a little bit. We've got $9,400 times 1.025 to the exponent 28. Okay. So if I do this multiplication piece, I'm going to do 1.025 to the exponent 28, because you always got to do the exponent first, times $9,400. So the final amount is going to be $18,767 and approximately 5 cents. Okay. So now, if I want to figure out how much money did William pay in interest, well, I take my A value of 18,767.05. My principal, I know, was $9,400, and I'm looking for my interest. And I know that interest is equal to A minus P. Okay, so my interest is going to be 18,767.05 minus 9,400. Okay, so the final amount of interest that William ends up paying is going to be $9,367.05. So William paid a very steep price, and almost double, to pay it back. Okay, so over the lifetime of that particular investment.